Alrighty, so here I am back in our PHPP. Hopefully, if you have been modeling along, you have a PHPP which looks something like the one here. You're getting good results for heating demand, cooling demand, peak heating load, and peak cooling load. We've modeled all the envelope elements. We've modeled our fresh air ventilation system, modeled all of our components, our windows, etc., etc. And at this point, we can turn our attention to our domestic hot water system. So let's take a look at how we're going to do that in our PHPP. So I've got my PHPP loaded up here, the same PHPP that I have been using all throughout this course. And so I am here on the verification worksheet. But what I'm going to do is down on the bottom here, I'm going to scroll to the right using these little arrow buttons. And I'm going to scroll to the right until I'm going to go past a bunch of worksheets here. I'm going to go past all these blue worksheets until the worksheets turn green. So in my version of Excel, there are these color codings here. You get these little color stripes on top. And I'm going to go to this worksheet labeled DHW plus distribution. So DHW plus distribution. This is going to be the worksheet where we're going to model in our hot water systems. So everything related to our hot water piping, our tanks, our hot water consumption, that's all going to be modeled here in this DHW plus distribution worksheet. So let me click on that one, and I'm going to just zoom out for a second. Let me come over here and let me zoom out for a second, and we'll just sort of take a quick look at the overall worksheet before we kind of dive into the nitty-gritty here, the pieces. All right, so we're obviously split up into a series of sections here. So we have a sort of a top chunk up here. We have another piece here in the middle. We have a third section, and then we've got a sort of final section down here at the bottom. So what are these different sections? Well, the top section, this very upper piece, this is a section of the worksheet which is related to hydronic heating systems. So if we were using hot water radiators to heat our building, we could model in all the various piping elements and whatnot in this upper section. Now we're going to skip over that in our case here. We're not going to use a hot water hydronic system for our building. Instead, we're going to use a heat pump heating and cooling system for our building here. We'll get into that in later sections, but we're just going to ignore this section up at the top here. We don't need to do anything here. But if we were modeling a hot water radiator, we have the opportunity to do that up here. Now the second section here, this kind of smaller section here, this is going to be dedicated to the hot water consumption. So we'll have a whole area here for hot water consumption. And then our big area in the middle here is all related to hot water distribution piping, both circulation and branch level piping. And then the last section down here at the bottom, we are also going to sort of skip over this section because we don't need this. This is for hydronic cooling systems. So if you have a cold water cooling system, there's some ability here to model in piping elements. Oh, and I guess I should also note there is a section here for hot water tanks. So a whole bunch of stuff in this worksheet, lots of different sections, but we'll go through it one section at a time. So let me zoom in here and we'll take a closer look at some of these and we'll start to model this out. All right, so let's start up at the top here. Let me make this a little bigger so that we can kind of see what we are up to here. All right, and it's a little challenging because it is a big wide worksheet. There's a lot happening here. Obviously there's a lot of pieces. Remember, of course, though, the only place we are asked to input any information are the yellow cells. There's not very many of those. Mostly here we've got a lot of calculation and results. There's not a ton of places where we're asked to input a lot of data. So it is a big worksheet, but don't be intimidated. There's not a ton that it's asking for us. So as I said, though, notice this entire upper section is dedicated to space heat distribution, meaning, of course, hydronic radiators, hot water heating systems. So if we're using a boiler to heat up water and then move that water to baseboard radiators, we would build out that portion here. Now, we're not going to do that in this little house. In this little house, I think we're going to do an electric heat pump system instead. So let's just skip over this and we'll skip down to the next section here. So the next section, the sort of middle section here on starting on row 45, labeled DHW useful heat. And let me zoom in a little bit here so that we can kind of see what we're up to. This is the section where we're actually going to model or input information around hot water energy consumption by our residents, by the people in the building. And notice here we've got some defaults in, and we also have some helpful hints here. So for instance, we're told that for domestic hot water for showers, a standard value of 4.2 gallons per person per day should be used for certification. And then for all other uses, we are going to use this 2.4 gallons per person per day. And notice there's some additional qualifications in those helpful hints there as well. Now, you might be thinking those are really low numbers, and you would probably be right. Remember, of course, that that's at 140 degrees, so you do have to consider how you mix that hot water down. But even then, maybe you're talking about maybe 7 or 8 gallons per person per day for a shower. That's a small number for North Americans, right? So that's a low number given typical North American patterns of usage. Now, of course, what's a good number for North Americans? I don't know. We could argue about that till the cows come home. Suffice to say that this is a low number, probably not all that correct for North Americans, but it is the number that we're told to use for Passive House certification. Now, of course, notice it is yellow, so you can change that number. I could go in and put whatever number I wanted. Now, where I would learn that number, I couldn't possibly tell you. But if I did, if I had a instinct or if I had a strong feeling about what that number should be, I can always input that number here. But for certification, we are asked to keep it at 4.2 gallons per person per day. Now we could talk about that at a later date, but that is how the PHPP is built. So, okay, so we'll just leave those for a typical residence. We can just leave those set at the defaults. We're building a typical single-family home here for this case, for this class, and so we can just leave those set to those default values. Now notice down below, we do have a couple of additional calculators here. So we have auxiliary, I can never say that word, auxiliary, better, calculations for domestic hot water demand. So if we wanted, we could build out a much more detailed demand. In particular, if we're doing non-residential uses, we're going to have to do that. The values up here, we should note, are only for residences. So the values up here in the defaults, these are only for typical single-family home residences. For any non-residential or more complicated use, we can use this calculator down here. Of course, to use the calculator, I have to come over here and press this little plus button to open it up. And so to do that, I'm going to have to unprotect the worksheet, as we've talked about in several previous lessons. One easy way to do that is just right-click on the worksheet and then say unprotect the sheet. And I can unprotect the sheet. Notice that little lock disappears. And now I can come over here and click this plus button, and I get unrolled a big calculator here where I can input, lots of information about, like, time of use for toothbrushing and cooking and drinking, and on and on and on. So we can build out a reasonably complex schedule here if we so desire, if we wish to. So this is built into the PHPP. You don't have to use this by default. This is really for more detailed residential if you feel the need to do that, or for non-residential uses. So I'm just going to hide that. We're going to ignore that for now. Now there is a piece here, there's another auxiliary calculator for shower drain water heat recovery system. So if I open that one up, now that one might be useful even for something like a single family residence. And in this case, we're able to model in, if you come over here, we can model in certain shower drain water heat recovery systems. We can input the performance values here, et cetera, et cetera. So if we were going to install a system like this in our building, we can model that in this case. So that is also useful. But I'm going to go ahead and close this and hide this. We don't need to go too far into depth there. Let's just say that we're not going to use either of those, and instead we're just going to stick with the defaults and keep the basic elements here. Now, I unprotected this worksheet, and so good practice, of course, is to come back down here to the domestic hot water and distribution, right-click, and say protect the worksheet. And of course, I'm not going to give it any password. I don't want to password protect it. I just want to protect it against any accidental breakage on my part, any accidental copying and pasting or deleting rows or columns or things like that. So I'm going to re-protect it, say OK, and notice this little lock comes back. So I've re-protected the worksheet here. And of course, that's good practice when working in the PHPP. All right, so for the most part, we can just leave this as is here. So let's come down to the next section then. So we don't have to worry too much about those guys there. Instead, let's continue on and focus on the next section. So the next section here has to do with our distribution. So here's where we're going to start to have to actually model in some elements here in order to calculate heat loss. So we are asked to input a whole bunch of information around the piping in our building. So the first thing we're asked to input is information around the circulation piping of our building. So this whole section here has to do with circulation piping. And then notice over here on the right-hand side, I can model 1, 2, 3, 4, and then I've even got another one. Where's the fifth? 5 banks or sets of piping. So we can model out, we can use that in all sorts of different ways to model out the actual piping in our project. This is for piping inside the thermal envelope. And then if we were to scroll over to the right-hand side, notice we've got a whole nother piping entry section here for piping outside the thermal envelope. That, of course, is going to be much more common in hotter climates. If you're not, hot climate, running your piping on the outside of the building might be a good idea. Down in Australia or Mexico, hotter climates, it might make sense to do that type of thing. Of course, in a place like New York State in the Northeast United States, that's not going to be a good idea. But there are plenty of climates where maybe that is a good idea. So you do have the opportunity to model your piping either inside the envelope of the building or outside the envelope of the building. And of course, we don't have to use all 10 of these. We only use whatever we need, whatever we want. We can use up to the full 10, but we certainly don't have to use all 10. And in our case here, we're not going to model any of our piping outside the building, so we're not going to input anything over here in this right-hand section. So we're going to keep ourselves restricted to piping inside the thermal envelope. We're going to keep all of our piping inside the building. And then, of course, we have to get into the question of, well, do we have a circulation system for this building? And what does our piping look like for this building? So in order to answer that, let's open up a new drawing. So we've put together a schematic level drawing of the proposed hot water system for this building. So this was not part of the initial drawing set, so we've got this now available on the Canvas website for download as an additional drawing. So let me pull up the Canvas website. So here's our Canvas website that we've been using to distribute files and to use as the hub for this class, of course. And you can see here that I'm in the module 3 of this class, and hopefully your Canvas website looks something like this. And as we saw in the first module for this class, we're able to distribute and share files in this Files section. So notice I'm in the Courses, and I'm in the third module here. And if I come into the Files section of this class, I have my example files folder just as before, and you'll notice that in the example files folder, we have a domestic hot water floor plans PDF. So if I just click on that, or if I save that, I can, save wherever I can, save the link. I can save that as a PDF, save it to my desktop. I can save that drawing. So make sure you download that drawing off the Canvas website, and then we're going to use that here to model our hot water system. So let me pull this canvas off to the side. Hopefully that all works for you. And now let me bring up that hot water drawing set. So here's that PDF. And let's take a look at what we have here. So we just put this together as a schematic. Turn these off. I'm not sure if I can do that. I guess not. As a sort of schematic level diagram of the plumbing for the building so that we can talk about how we're going to model it. Now, I think for this building, as a very small building, I don't think we need a recirculation system. We could discuss it. Maybe you do think we do. Maybe you think we need a recirc system to the upper level bathroom, but I don't think we do on a building of this scale. And so in this project, to keep things as simple as possible, we're going to not include a recirculation system. Instead, we're just going to have a series of branch pipes. So let's talk a little bit about how the system is configured, or the proposal for the system configuration. We're going to have our hot water tank here in the mechanical space. And the hot water tank is going to feed a main sink in the kitchen, as well as a second sink and a bathtub or a shower in the bathroom here. And then if I was to go to the second floor plan, I'll come over here and go to the second floor plan. Remember, on this building, we have a small bathroom on the upper level, and so we have another sink and another bathtub or shower. And of course, we're going to have a vertical riser there for the hot water to get up to the second level. So pretty compact, all things considered, kind of. I mean, it would have been nice to stack those bathrooms one on top of another, but you know, it's a small building, so not too big of an issue. But obviously, we have all the information we need here in order to model in our branch level piping. But as you can see, there is no recirculation system in the building. So there's no recirc system that we need to concern ourselves with. So what does that mean for our PHPP here? Well, what it means is that we don't need to put anything here in our recirculation system section. So we're not going to model anything here in the recirc system. We can just skip right past it down to the next section here. And in the next section is where we're going to be asked to input our domestic hot water individual pipes. So this is the section where we're going to need to start building out our hot water piping. So I do think, though, that we should take a break here. Hopefully as a good introduction to the domestic hot water worksheet. And when we come back in the next video, we'll turn our attention a little more seriously to the question of how are we going to model in all of these pipes? How are we going to keep track of all of these elements? That'll take us a few minutes, so we don't want to rush through that. So let's break this video here, and we'll come back in the next one, and we'll take a look at exactly how we're going to model out all of those various piping elements.